Hello everyone, good morning and welcome to today's tutorial. Today we are continuing to treat partial fractions with repeated factors. In the previous videos we looked at the concept of repeated factors, and in this particular example we are going to have a denominator composition of a repeated factor and a linear factor. So I want you to follow me as I go into the breakdown of another way that you can have questions on repeated factors. Now when you look at this denominator here, you have x plus 3 and x minus 1 all squared. So you know that this x minus 1 squared is a repeated factor in this expression, and x plus 3 is a linear expression. Now this is a game changer because now the number of partial fractions that we need is going to increase to 3, because you know that we are picking out 2 partial fractions from this particular denominator, and this makes it the third. So if I'm going to write the equivalent of this particular expression, we are going to have 5x, that will be a over x plus 3 plus b over x minus 1, and we leave this, plus c over x minus 1 all squared. Now you can see that this is the linear factor and this is the 2 other repeated factors of this expression. Now we need to find the value for a, b, and c like we usually do. So the next thing we need to do is to take the LCM of these three values, and when we do that, we're going to have x plus 3 and x minus 1 all squared. Now, so here we try to solve for the numerators now. This is x plus 3, so if we divide 0, you'll be left with this. So you have a into x minus 1 all squared. Then b is a combination of x plus 3 and x. B here has is x plus 1, right? So that means if we remove one of the x plus 1 here, we let the x plus 3 and one other value for x plus 1. So this will be x plus 3 and x minus 1. So instead, then our c value for c here is x minus 1 squared. So if we bring it down here, it's just going to remain this, we left with x plus 3. So the value that we left here is x plus 3. So this is what we have here. Now, so obviously now we have gotten the values for our numerators for the partial fraction side. Now we're going to make it equivalent to this particular expression. That will now be equals to equivalent to 5x squared minus 2x minus 19 over x plus 3 and x minus 1 all squared. Since we both have the same values for the denominator, we don't worry. So we just take the values for the numerator and group them together. Just like we did in previous videos, we are going to find figures that we can use to turn some of these values to 0. Now here I'm going to turn this particular expression to 0. I need to make x a positive 1. If I want to make this expression a 0, I need to make this x a minus 3. So that's what we're going to first do. Look at how we can eliminate the various expressions to get our variables that we have in our question. Now, so we are equating that with the numerator in this particular expression. So let me bring this back to this side. So we have 5x squared minus 2x minus 19 equals to a into x minus 1 all squared plus b into x plus 3 x minus 1 plus c into x plus 3. So let's say let x be equals to 1. So we put value for x on both sides of this equation. So we have 5 into 1 squared minus 2 into 1 minus 19 equals to a into 1 minus 1 squared plus b to 1 plus 3 1 minus 1 plus c into 1 plus 3. So in this case now we have 5 minus 2, which is 3 minus 19, which is minus 16. So we have minus 16 equals to, let me pick another marker. Minus 16 equals to, this is very going to be 0. When you also take Cardinal expression, 1 plus 3 is 4, 1 minus 1 is 0, 4 times 0 is going to be 0. So we are already left with the expression for C. So that's going to be 4C. So that's 4C. So if we divide both sides by 4, our value for C is minus 4. I get me now. Now, so let's make x, let x be minus 3. I hope you are following me. So let's make x minus 3 now. So we have 5 into minus 3 squared minus 2 into minus 3 minus 19 equals to a into minus 3 minus 1 squared plus b into minus 3 plus 3 minus 3 minus 1 plus c into minus 3 plus 3. Now if you look at this expression, c will be removed, b will be removed. We are going to be left with the value for a. So on this side now we have 9 times 5, which is 45. 45 minus this plus 6 now minus 19 equals to, this is a and minus 4 squared. So now, for the sake of our tables, again, I'm going to clean some of the expressions that we are getting up here. And we're going to continue the work that we are doing here. So I'll write out this expression again. Let me just pick this corner. I hope you are following what we've done here already. So let me repeat what I've written here now. So we have 45 plus 6, that is 51 minus 19. We're going to be left with 32. So when you do the addition and subtraction, then you should have 32 equals to 16a, right? So this is 16a. So if I divide both sides by 16, a is equals to 2. So we have a value for a and a value for c. Now we need to get b. Now when you look at the expression for b, let me complete this particular side. C into x plus 3. You look at, when if we expand these b variables, we are going to get a quadratic expression. So we are going to expand x plus 3 and x, this particular expression. So we say expanding b into x plus 3 x minus 1. So we know we already have b to get. We have gotten the value for a and c. So we say, so when you expand x plus 3x plus x minus 1, you should have x squared plus 2x minus 3 and then into b. So if you multiply through by b, you will have bx squared plus 2bx minus 3b. Now, let's remember this particular expression. We're going to equate it with this expression, since this is also a quadratic expression too. So if we equate it, that will become 5x squared minus 2x minus 19. So you can see that bx squared and 5x squared, 2bx and minus 2x, those are expressions based on the x that they carry. Now this carries a x in the power of 2, it also carries. So we are going to make this, we are going to make these two equivalent. We make them equivalent expressions. We said they are equivalent from the start. I already made them equivalent. That means that bx squared is equals to, or is equivalent to 5x squared. If we eliminate x squared from both expressions, we'll be left with what? B equals to 5. Get that now? So we have the value for a, b, and c. A is 2, b is 5, and c equals to minus 4. Now let us write down, let's put down all of these values into the context of what we got earlier. So that means that now we're now going to have 2, so our final answer will be 2 over x plus 3 plus b is 5, right? 5 over x minus 1. Then c is minus 4. That means that the sign here will change to minus. I'll say minus 4 over x raised to x minus 1 all squared. So this is the partial fraction expression of this particular work that we have just done now. I'm going to go through all my explanations from the beginning and see whether you are able to get and apply it to your own personal work. I will be dropping a link to some practice exercise which you can go through if you want to. So we have come to the end of today's tutorial. I wish to get your feedbacks and comments on what you have just watched. Let me know if it is well explained and it has benefited you. Remember to share with your friends. It's going to benefit them also. Thank you so much.